About what a parametric equation is. We looked at a parabola as a parametric and a line, correct?
Yes.
Today I'm going to show you what a circle and an ellipse and something called a cycloid looks like. And then I'm going to show you what slope looks like. Okay. The important one there being slope. All right. So a circle. Center AB and radius R. In pre-calc, you look at this equation. So that would be the coordinate plane version of a circle. You have the center and the radius that define position and size, right? So that's, now the parametric version is not a whole lot different. It just has an x and a y component like we talked about yesterday. So the x is the a plus r cosine theta. You'll always notice that x and cosine go together. And y equals, guess?
B plus r sine theta.
Yeah. And there's your parametric circle. Be able to recognize it. You better recognize it. Is that enough? You want me to draw one or write one out or what?
Draw one.
So, let's see. Let's go with 1 plus 2 cosine theta and 3 plus 2 sine theta. Fortunately, the radius r is always the same, right? There you go. Flathead circle. So it's not a circle, but it's good it's going to get right now. So the center is at 1, 3. The radius is 2. Okay, ellipse. Pretty rare to see it in calc, but do you remember the pre-calc formula for this?
No. That was like,
It's centered at origin.
So like x plus a squared over plus y squared over e squared.
You copy and paste.
Shut up.
There's centered at the origin.
Shut up.
We know.
The fuck is right here.
I know.
Okay, A is the major axis. Do you remember all this stuff? Major, minor axis. Major axis A, minor B. Depending on whichever's larger. Right? So if B is larger, that's the major axis. Right? A is larger, that's the major axis. So keep in mind those can change. You can have a vertically placed ellipse, but that's all that defines it. A unit's one way and B the other, and you got your ellipse if it's centered at the origin. Okay. Okay, let's look at something called the cycloid. It's something you've never seen before. It's really
Look like a
neat.
bean?
No. Imagine that you're on a bicycle and you put a dot on the tire.
Okay.
What path is that dot going to follow?
Circle?
No.
Ellipse?
Nope.
What?
Cycloid looks like this.
Why?
Yep. See, there's your point on your bike tire, right?
That makes complete sense, but, oh.
So as the tire spins, that's the path that's traced out. Right? And if you just keep going, boing, boing. Okay.
See the free body kind of thing?
Yeah,
Kind of funky, isn't it? Okay. This cycloid just happens to be pretty standard. But we can change so this has a radius of 2, I believe. So if we set the radius at 1 for this value, it changes how the cycloid spins and traces it. Right? It's the same general shape, but you just have the dot in a different spot. Okay. But we do like to just keep it like the first one I showed you.
Do you guys know why we have to lay this today? Because it's hump day.
Get out.
I was stupid.
What?
Did you know why I have to learn this today? Because it's hump day and I'm pointing to the graph.
Yes, I timed that perfectly. I even cut my thumb off so Mason could make that joke.
Yes! It all circled back.
Oh, look at that! Another joke about the math. It all circles back to what we want to do. Okay, so that's a cycloid.
For years.
All right. So you have what factors are governing the cycloid?
Height, radius.
The radius of the circle. Okay. What else?
What's a cycloid? That use physics.
This. Boing.
Happens when a fish point rotates around a...
Put a dot on your bike tire. What path does that dot follow? That's a cycloid.
It's not the same.
Okay. So you have the radius of the circle really is what governs the cycloid. You can again change it so that the dot's not on the outside of the circle. Okay, so it can be on the inside or the outside. That's when it gets really fun. Right. Whee! That would make a really fun roller coaster. It would.
Be all for it, but you drop
Drop it 90 degrees.
Yeah.
Oh, 180 degrees. That would break you.
It probably would, yeah.
Sounds like something Six Flags would do.
Okay,
Not legally, but
It's Six Flags, what about them legal?
so here's the equation for a cycloid.
Yes, I do. Okay.
I heard that cycloid and I don't know why.
Hold on a sec. And this, oddly enough, breaks the sine cosine y relationship and x cosine relationship. So,
Is it switched on?
yes.
Well, that's gonna be annoying.
Yeah, it is.
No, it's gonna be a really easy to find it.
Yeah, so if you see the y and the cosine together, you pretty much know it's a cycloid, right? Or an x and a sine. So there's your
What cost?
equation based on radius of a circle.
Yeah, I did. You lost it there.
So there's your basic cycloid. It does come up once in a while in our work, but it's pretty rare. Just a neat thing to look at.
It's really good if we run a circle.
Eyes across the
Okay, here's what we really care about. Here's what I really care about anyways. Slope of a tangent line. So how do you calculate slope in math?
You idea?
dy dx, right? Same process here. So if we have a parametric, right, it's the x and the y. How do we calculate dy dx?
Y.
Yeah, pretty much. dy dx is y prime at t over x prime at t. It's the y's and the x's, right? So you take the y function, derive it, and the x function, you derive it. If you have something in this form, that'll do it. So just, again, it's the same relationship, dy dx, just changing y, we're changing x. So derive the y and derive the x and slap them on top of each
So
other.
you can you do all like the normal calculus stuff with a parametric equation? Like derive, integrate, and what can be asked on the
We
test?
will only be worried about derivatives. And we'll talk about, because there's a time component of parametrics, speed comes
So when
into
you're
play.
doing that, do
And
you
then
do
we'll also talk about arc length. And arc length and speed are two equations that you've actually worked with before.
so
They're
for
just put
the
in parametric form.
derivative, you do y prime over x prime?
Yeah, so
as
let's,
if it wasn't a division.
Let's say that x equals t squared plus 1, and y equals t cubed minus 4t. Now I've written it different than this, right? Two different ways to write parametrics. So let's calculate dy dx.
Would you use the division rule in derivatives?
At t equals 3. So what's dy dx?
3t squared minus 4 over
Y prime or x prime, right?
Yeah. It's like a
So what's the derivative of that?
3t squared minus 4.
Over?
You plug in the 3, right?
Now plug 3 in.
So you do treat them separately and then divide
Yeah.
it?
23 over 6.
So,
Dude, I almost guessed this one.
That's what it's called, not division.
Yeah, I didn't even know what you were talking about.
Like, talking about quotient rule.
yeah, no quotient rule here,
Okay.
just separate. Alright, so we get 23/6. What's the equation of the tangent line?
Y minus y1, so y3 is 9 minus 12. Negative 3 equals x. y1 23.
Why at one is one?
Okay, well, y1,
Why do you need y1? Not 3.
that's the equation, right? Same equation we've always used for tangent line.
Minus 15 y 3.
Plug 3 in.
Yes.
So it'd be y minus 15.
Oh, that's cute.
Yeah, so 27 minus 12, 15.
Minus
And then we have our slope,
23/6.
and x minus 10.
All your plus is in.
Because I can add.
Okay. Oh, because this is the time.
Okay. Good.
Yeah.
Or is there a horizontal tangent line?
Were they both equal 0? Were both x and y equal 0?
Did you say the derivative equal to 0?
Okay, so
Horizontal tangent line is slope 0.
now put that in terms of this right here. Which one of those has to be 0?
X. No,
Y.
The y has to be 0. Can the x be 0?
Yeah.
No, that would be undefined vertical, right? So all we need to worry about is y prime equals 0. Okay. So 3t squared minus 4.
Square root of 4/3. Whatever that monstrosity is.
Sure. Do either of those points make the denominator 0?
No.
Do any of them make x prime 0? No. So we're good. Okay, so always check.
Wait, is 0 0 not 0?
Sure. X prime.
0 over 0 is undefined. It's
not
terms of
0?
form.
Oh, I thought it was 0.
How many times can 0 go into 0?
0 times, because it's
An infinite amount of times.
You can pull nothing out of nothing forever.
It's like if you share
That's so
You
zero.
can pull nothing out of nothing, never.
Exactly, get wrecked.
I kind of want to ask.
So it doesn't
zero,
equal
but
0,
it's
equals
zero.
Why is that an indeterminate form, 0 over 0?
I
You
want
can't
to.
divide by 0.
I want to ask zero.
You can divide zero by zero.
Zero is because zero has the best response.
Huh?
Zero's response to 0 divided by 0.
What is it?
I'll show you after class.
Oh, I was gonna hold on, I know.
You want your phone taken away?
Nah, that's a good question.
All right, so this again is what we see most often, putting those derivatives into use with parametrics. Okay. Do you have any questions? I wrote down the work yesterday. Do you need to write it again? Okay. The rest of the time's yours to work on it. Because I need to sit down.
Yay.
I've discovered that cutting one's thumb off makes you really tired and pain.